So welcome for the third part of the class, that is the kinetic theory of gases. Here we will discuss, in the first we will summarize the previous class, what we discussed so far. I mean just the most probable velocity, RMS velocity and the average velocity. What we did, that we found the different the values of the most probable velocity as well as the average velocity and RMS velocity. So here it is basically, this is the CRMS, that is the root mean square velocity, that is the 3 root under 3 RT by m. And I told you that here what we have seen, that the velocity RMS, the root mean square, as well as the average, as well as the most probable velocity, both the three are basically directly proportional to the square root of the temperature, and the rest terms are the parameters, that means the constant. Okay, so here this is basically the expression. So from these expressions you can understand that distribution of the molecular speeds, and here again I am just giving you that these two graphs show the distribution of speeds of molecules in a gas. So derived by the Maxwell, and the most probable velocity is not quite the same as the RMS speed. Now the question is that if the temperature will change, then how it will respond. So here that the response is just showing here. You see that at 273 K, here we can see that that means the 0 degree centigrade, and after that if we will take the 37 degree centigrade, so there is a shift of the most probable velocity part. So it will change. That means due to that the most probable speed, the average speed and the root mean square speed all are related with the square root of the temperature. So there is a certain change you can observe from here. So that is the relative number of molecules. So the curve shift to the right with the temperature. So then this is the assignment, that how we can find out the velocity for obeying the Maxwellian, the classical Maxwell-Boltzmann statistics. Based on this, we already did these calculations. So we already showed in the previous discussion on the previous lectures. So now I am not going through on that. So now we are studying the new topic, that is thermodynamics. So thermodynamics is also the part of the kinetic theory of gases, because the thermodynamics means, the literal meanings of the thermodynamics is the thermo means heat and dynamics means the energy, kinetics. So this is basically the thermodynamics is the branch of science where the phenomena of energy and related properties of matter, that is especially the laws of transformation of heat into other forms of energy, and vice versa. So the thermodynamics, in my opinion, the first this was observed by the great scientist, that is this is the great scientist James Watt, right? The James Watt, what he observed, that when the water is boiling inside a kettle, and there is a lid is already given, and then it was that the lid was just basically getting this it will stuck on the, that means that due to the steam, generating the steam, that will coming up, right? So this is one of the best example that using the heat we can get the energy and the kinetic energy, and that also after that we are transferring it in the motor system, the motor engine. There we are doing the same things. After the steam engine there is a diesel engine, then and so on. So I am not discussing in detail on that, because in your class 2 level you have enough knowledge on that. But the macroscopic approach and what is the microscopic approach towards the thermodynamics. In this approach we do not follow the behavior of the individual molecules. So it is a bulk molecules we are considering as a bulk, and the analysis of the macroscopic system requires simple mathematical formulae and the values of the properties of the system are their average values. So that is a macroscopic approach, and when we are coming to microscopic approach, then we are considering that the gas molecules are it is a large number of molecules are present there, and these molecules have different velocities and energies, right? So number of molecules is a very large, and so the approach is little bit complicated compared to the macroscopic level. So now the thermodynamic systems. What is the thermodynamic system? The thermodynamic system may be defined as the quantity of matter or definite region in space upon which some thermodynamic process is taking place. Thermodynamic is basically, there is a lots of things, lots of terminologies are also involved, like boundary, system, surroundings. So we will discuss one by one. Now the space outside the thermodynamic system is known as surrounding. Like suppose in a system like the refrigerator, I'm just giving a simple example. The refrigerator is basically used for cooling the systems. So if we are considering that outside of the system, that is the surroundings, there is no effect in the surroundings. So the space outside the thermodynamic system is known as the surroundings. So in the refrigerator, inside it is heating, it is cooling, but outside what is happening? Heating. So similar things in the AC, the air conditioning systems in your home. You don't know that how much heat is basically you are releasing from your room to outside the surroundings. So there is exchange of heat, that's why you are feeling cool. So this is basically the thermodynamical systems, and surroundings is the atmosphere, and your room is basically the thermodynamic system. Okay, so now you can understand these things. Now the boundary. Boundary is the line separating between the system, that means thermodynamic system, and the surrounding. So this is called the boundary. What is the universe? Universe means the total system. That means the thermodynamic system, surrounding, boundary, everything when we are combined together, everything will be considered as the universe. So this is the part why we are saying the universe. Now the state of the systems. What is the state of the system means? State of the system means the thermodynamic state is a macroscopic conditions of a thermodynamic system as described by thermodynamic parameters like temperature, pressure, density, compositions. These are all affect the system. So that's why it is called the state. So the state means the pressure, what is the parameters involved in this system, the thermodynamic system, that is the pressure, volume, temperature, density, compositions. So these are basically the defining as the state. Okay, so now we are coming to the other things, that is the cycle. Now we are considering what is the cycle. Cycle means that when the process is connected is like a ending, starting from one end, and after that it will again come back to the initial state, then it is called a cycle. So you just see here, this is just showing you the very good examples of a cycle. So I am just explain this part. Here you can see that first we are considering two, and one is a process A. Okay, so suppose from 1 to it will just come to the 2. So in this case what is happening, you see here V is the volume and P is the pressure of the system. That I told you, the state of the systems are basically the parameters like pressure, volume, that means which will basically change the thermodynamic system with respect to the surroundings. That is basically here saying like this. So here you see that the cycle, when we are considering the cycles, that from 1 to 2 it will go this way, and when it is coming to 2 to 1, then we are saying it is a process A, and when it is coming to 1 to 2, then we are saying it a process B. So a cycle is basically composed of two processes. One is process B and another is a process A. And all other thermodynamic properties must also change accordingly. So here what is changing means when it is going to this following these two paths, it basically if it is gain the energy, then here you are basically lost the energy if it is a reversible process. Anyway, I will discuss it later, what is reversible and what is irreversible. So the thermodynamic properties must, in this case what is happening, that other thermodynamic properties must also change so that the pressure is a function of volume as described by these two processes. So when it will change, suppose when it will go to 1 to 2, means what? That here what is happening, the volume is increasing but pressure is decreasing. Similarly, when 2 to 1, then pressure is basically decreasing and the volume is increasing. So in this case volume is decreasing when we are going to 1 to 2, but pressure is increasing. But here when it is coming to 2 to 1, then pressure is decreasing and pressure is decreasing and volume is increasing. Yes. So that is, the two process is basically just opposite. So then it is called the cycle, right? Now equilibrium. What is the meaning of the equilibrium? There is this equilibrium means the same. So how we can say these things? Thermodynamic equilibrium, then thermal. One is a thermal, that is uniform temperature. If it is uniform temperature, then it is called the thermal. Mechanical means uniform pressure. If the system just carrying the uniform pressure everywhere, then it is called the mechanical systems, then the mechanical state of the system. And then phase state of the system means phase equilibrium, and last is the chemical equilibrium, means there is no change in chemical state. So then we can say it is a chemical equilibrium systems. Okay, so now here I am just giving one evidence that how it is changing, right? So you see here the systems means 32 degrees centigrade the temperature. If this is a container, this is a thermodynamical systems, then you can see here everywhere, if we will just take the temperature, we will see that it is 32 degrees centigrade everywhere. But in this case it is no thermal equilibrium. How I can say it? If the temperature is in different zones are different, like 20 degrees centigrade, 30 degrees centigrade, here is 35 degrees centigrade, so there is no thermal equilibrium. We cannot see it any thermal equilibrium of this system. Now there we will discuss one point, it is very important, that is a quasi-static process. So what do you mean by quasi-static process? Quasi means what? The same, nearly to the same, right? So here the process proceeds in such a way that the system is basically remains infinitesimally close to an equilibrium state. So it is not exactly the equilibrium state, it is close to equilibrium state. So what do you mean by equilibrium state? It is equilibrium means, that means the state of the systems are not changed very fast, then it is called the equilibrium state. And we cannot, it is very ideal concept. So because it is not possible, right? So that's why we are saying it is infinitesimally close to an equilibrium state. Infinitesimal means what? Infinitesimal means which you can think less than of this, then it is called the infinitesimal, right? So it is called a quasi-static or quasi-equilibrium. That means it is near equilibrium conditions. Equilibrium means the state of the systems are not changed, right? So now the quasi-static process, if we can understand this, then we can go to the, it is a very sufficiently slow process. How I can give an example? I am just giving one example. Suppose the container, in a container there is a the closed container, there is a piston, right? Now I am just push this piston towards the container, I mean towards that means the volume will change, the pressure is basically increasing, right? If I will do it very fast, then what is happening, and if I will do it slow, then what is happening? Now I am just giving these examples like a cycle pump system. I think the cycle tower, you people are giving the pump on the system, the tire, the tire tube, which is in the cycle, the bicycles, which you are basically there, we are giving the using the pumper system, right, or the football. So bladder system, there we are just giving the air. If we will do it very fast, that means the compression and the expansion, compression and the expansion of the piston. If we will do it very fast, then what is happening? That is actually the temperature of the systems will increase very fast. Then it is not isothermal. Now, if we will do the same things, but we will do slowly, very slow, sufficiently slow, then what is happening? That the temperature is not changing appreciably. Why? Because the temperature is changing, but this temperature is basically radiate to the surroundings. So ultimately there is an equilibrium. So that's why the important the terminology surroundings, the surroundings and the thermodynamical systems are very important. They are basically near, I mean, the how they will how they will pass the parameters like temperature, how they do these things, it is through the across the boundary. So the terminology like thermodynamical systems, surroundings, boundary, universe, these are all very important terms to understand the quasi-static process. Okay. Now this is the graphical representations from where you can understand that what is the quasi-static process. So what I just discussed in my previous slide, here you can see this is a piston. So this piston is the initial state was this, the fed part, and when we are just applying the force, that means the pressure, then it will go to near to this. This is the final state. So when we are approaching from initial to the final state, then what is happening here? You can see that the process path when we are going to 1 to 2 is basically the volume will change. That means it will decrease, and correspondingly the pressure is increasing. So if we will do it slowly, sufficiently slow, then we can avoid the temperature is increasing. So it is, we can say it is isothermal process if we follow the quasi-static way or quasi-static process, right? So then it is called the isothermal process, means the temperature is the same. So this is the same things, it is just showing in that the previous curves. Now I am coming to zeroth law, which is the first law formulated and labeled by R.H. Fowler, that two bodies, if they are in equilibrium, if both have the same temperature, even if they are not in contact. So that I am just saying that across the boundary from thermodynamical systems to the surroundings, if the heat is conveying, then only we can say that it is in thermal equilibrium. That means in the quasi-static process is basically maintained. That means when we are changing the volume, that means from volume is changing from its one state to another state, that means the volume is decreasing or increasing, then the temperature will not change. If it will do it sudden, then only we can see the change is happening, right? Now, what is heat? Heat is a form of energy that is transferred between two systems or a system that its surroundings due to temperature difference, right? So heat is basically the energy in transition, and the temperature is the effect that we know, right? It crosses the boundary of a system, and then only, now here I am just giving one examples that what is the surrounding, what is the this here, using this easily you can understand that here you can see this is a baked potato, and this baked potato you can see this is the surrounding is the air, and here we are just giving the energy, and this is the this part is basically the boundary, right? This is the boundary, and this is the thermodynamical systems. So here we are applying the this by the boiling systems. That means we are just incorporating the air here, the heat here, and then these systems are getting heated, and but this heat is not coming out because of this peel. This is the boundary. So this is one examples, good examples of the baked potato, that we can see that the contains energy, but this energy is heat transfer only as it passes through the skin of the potato, or that is a system boundary, to reach the air as shown in figure. So here, from here you can understand that what is the surroundings, what is the this is the boundary, and this is the thermodynamical systems. So entire this is are present in the universe. So if we can just, this is the thermal energy, so this is a good examples of the same. Now, so this is we are just concluding here, and in the fourth part we will discuss about the next things, and I will summarize before coming to the next one. Okay.